Hello everybody. This week we're doing 11.5 and 11.6, and I'm going to give you the option of doing the homework page questions, or you can do just a few problems that I'm going to tell you what to do as I go through the video. So it's totally up to you what you want to do. So we're doing a volume of prisms, cylinders, and pyramids. So the first thing I want to do to help explain this is I'm going to use my textbook as an example of a prism. You all should know what a prism is by now. The top and the bottom are the same, and it has a height. And my teacher book is going to be a little bit different than yours, but I would ask that you find something different, either a box, a piano bench, something like a rectangular prism, or it could be a square prism. It doesn't matter. If you have something odd, that'd be great. But take a picture of it and find the volume of it. Or do the homework questions that are on the homework page. And again, I just want you to do the odds of those if you're going to do those. That way you have the answers, and you are required to check the answers. All right, otherwise, you can do something like this. So I'm going to draw the book here, and this is what my geometry book looks like. Okay, and I'm going to measure the height of all those pages. All right, but not yet. The first thing I want to do is find the area of the base. So the volume of a prism is equal to a capital B times H. Capital B stands for the area of the base, and then times the height. And that's for any prism or cylinder. So if you had a triangular base, you'd have to know the area of a triangle. If you had a pentagonal base, you'd have to know how to find the area of the pentagon. And we're not going to do those. We're going to stick to squares, rectangles, trapezoids, and triangles for what we're doing here. So what I have here, the top and the bottom of my geometry book, is a rectangle. So the area of my rectangle is base times height. And don't confuse that with the height of the or the thickness of the book. Okay, so now let's go ahead and figure this out. So I'm just going to use the pages, not the cover, on purpose. So the length of a page of my book is not 8.5. It's not 8.5 by 11. It's 9 inches wide. So 9 inches wide. And if I measure the height of a page, I get 10.75. So 10.75 inches, 10 3/4 inches. All right, so I put that into my calculation here, 9 times 10.75. And then the height, the thickness of all the pages together is going to be, again, 1 inch and 3/4. Oh, I'm sorry, 1 inch and, let's see, about 1 inch and 1/4, so 1.25. 0.25 is 1/4. So now I have all my numbers. I can get my calculator out, and I can do my calculation of 9 times 10.75 times 1.25, and that gives me a volume of 120.9375 on my calculator. Okay, so what is that? Area is the square inches. How many? We're doing this in inches, so we're doing square inches. How many square inches go into your picture? Okay, so there's 9 there, and then 10.75 going up. So you multiply those together, and then you multiply it by the height. That's how you get the volume. Okay, so the area of one page, I'm just explaining this a little bit differently here, 9 times 10.75 is 96.75 square inches. That's how many square inches are in a page of my teacher book. And to get the volume of the book, that would be cubic inches. How many cubes of inches go into that? If I draw this a little bit better here, there's a cube inch in there, and then a little bit left over. Remember, it was 1 1/4 inches thick. So how many inches cubes will fit in that book? And if you multiply it by the 1.25, you'll get 120 cubic inches. So it's really simple how to find volume. It's the area of whatever the base is times the height of your figure. So if I took all my pages, now this is something a little extra here and I want you to think about. If I look at the number of pages in my book, and it comes to the actual numbered pages are 727, and I got about 1/4 of an inch of extra pages. So let me figure out how many pages that is. So I have 728 pages plus an extra 146 pages that are numbered by letters and stuff. So I actually had to count those. So I add those together, 728 plus 146. There's 874 pages in my book. All right. Okay, so I can find the volume of each page. When you think about volume has some thickness, and pages don't really look to have any thicknesses. But yes, of course, a page has a thickness. We just can't measure it. But here's a way to do that. If I take 120.9375 and divide it by 874 pages, each page is 0.138 cubic inches. So very, very small, but I can find how thick or how much volume a page has. So I could actually crinkle up one of these pages into the form of a square, and obviously it would not be a cubic inch. So if I draw a cubic inch here for you to give you an idea of what I'm talking about, if I folded my one page of the book up into a cube, it actually would only be about 0.138. 0.25 is 1/4, which is about right here. So 0.138 is going to be very, very small. Even if I took the page and folded it up into a square, it would only be this thick, which you know that. If you folded up a paper into a square, it wouldn't be very thick, but it'd be about that thick. And that tells you that this works. So in general, the volume of my book is 120 cubic inches. How do you find volume? It's the area of the base. You got to figure out what the base is of whatever your figure is and multiply it by the height. So as we go on, if you want to know, you can look in your book or you can see here. So a square, everybody knows that. The area of the square, I'll do area here for you, is the side squared. Okay, that's base times height. And base and height are the same in a square. That's why it's s times s, or s squared. And you have a rectangle, which is length times width, or base times height. It doesn't matter how you say it. And you have trapezoid. Trapezoid, you probably have forgotten what that is. Trapezoid is 1/2 base 1 plus base 2, the top and the bottom bases, and then times the height. All right. And then times the height of the actual figure. So let me just draw a picture here. So I have a rectangle at the top and a rectangle at the bottom, and I connect everything. That would be a trapezoidal prism, okay, where the front face of this and the back face of this is a trapezoid. You can't use the top and the bottom. The top is a rectangle and the bottom is a rectangle, but they are not the same size and shape, or the same shape, but they're not the same size. They have to be the same size and the same shape. So the front and the back of this trapezoidal prism, it's called trapezoidal because the front and the back are trapezoids, and those are the same size and same shape. So you have to find the area of the trapezoid, which is this piece right here. And then you multiply by the height, or the depth, would be this piece right here, and that would give you the volume of that trapezoidal prism. That's just in case you're going to do your homework page. All right, and then obviously a triangle, area of a triangle is going to be 1/2 the base times the height, which everybody should know. And that's good enough for now. All right. You also have kites and other things, rhombuses, but we're not going to do those. All right, so that's how you find volume. Make sure you find the area of the base and then multiply it by the height. Now I want to do a cylinder. All right, so the cylinder, I'm going to I have a big can of Arizona green tea in front of me. So here is the shape of this cylinder. Okay. And what I need to do is to find the volume. Again, it's capital B times H, which the capital B stands for the area of the base. The base is a circle, so the circle formula for area is pi r squared. And if I multiply it by the height, that will give me the volume of the can. Okay? So I need the radius to find the area of the base. So I need to measure, take my ruler, and I'm going to measure the diameter of this. It's easier to measure the diameter. 2 3/4 inches. This is a big can. So 2 3/4 inches, which is 2.75. That's my diameter. I need to divide it by 2. So my diameter is 2.75. The radius is 1.375. So the volume of this would be pi times the radius, 1.375, squared. That gives you your area of your circle, times the height, and I need to measure the height of this. And the height of my can is 7 3/4 inches, so 7.75 inches. Now all I do is take my calculator and figure it out. So I take 1.375 squared. I need to do my exponents first, and then times it by pi on my calculator, and then times 7.75. So the volume is 46.03 cubic inches of tea in my Arizona green tea can. So I hate tea. I do not drink tea. This is one of my family members. So what I have done is I found a can for a cylinder. You can use a soup can. I'm sure you have cans of stuff in your pantries. You can find a box somewhere. As I'm looking across my room, I have a actual photo album that is a big rectangular prism. I have tons of books I could use. Let's see, what else? Oh, I have a cylinder that is a box cylinder that is the shape of this can that is actually pretty big. It held a poster in it, so I have that I could have used. A candle looks like a can. You could find that. I saw some pictures from the last few sections. People sent me pictures of candles. So you could do that. So I'd like you to do either the homework page numbers, or you can take a picture of a rectangular prism or triangular prism, whatever, and also a cylinder, and give me the calculations for that. And then that's 11.5. So 11.6 is the volume of pyramids. So here's the difference. For those of you who think this is going on too long, it really is about to be over. The volume of pyramids, again, is the area of the base times the height, except a pyramid, if I draw a, let me just draw a square prism here. A pyramid is still the area of the base. So you still have to find the area of the base, no matter whether it's a pyramid or a prism. That still has to be, you have to identify what the base is. And in this case, I'm saying this is a square, so you know what the area of a square is. And then you multiply it by the height. Yes, that's still the same for pyramids, except for this. A pyramid looks like this. So that would be a pyramid inside that prism. So there's no way it can be identical to the volume of a prism. It is 1/3 of the volume of the prism. All right, so I'm not going to ask you to find a pyramid in your house. If you have something that is the shape of a pyramid, you may take a picture of it and use it, or you need to do the problems in section 6. So I'll do one problem as an example from section 6, and then I'll tell you what problems you can do. Now, I know at the beginning I said you had to do the homework page numbers, but if you're going to take pictures for section 5 and send them to me, I'm going to shorten what you do for section 6. Otherwise, you have to do all the problems that are listed on the homework page, the odd problems. All right, so here's an example of a volume of a pyramid. In, let's see, section 6 on page 639, if I do, let's do number 6. There's no picture, it's a word problem. It says a pyramid with a square base. So I'm going to draw a square base. So all the sides are the same and it's 90-degree angles. Has a volume of 912 cubic feet. All right, so what they're doing here, since they already know you know how to find volume, they're going to ask you to find a missing piece. So we'll go ahead and do this one. So the volume, again, is 1/3 the area of the base times the height. In this case, the area of the base is base times height, but there again, that's just the side length. So S times S is S squared. And then times the height of your pyramid, okay? Again, this H is not the same as the height of the pyramid. Okay? So they're saying the volume, now we just fill in what they gave us. The volume is 912 cubic feet. Okay, we don't need the units until we're done. Equals 1/3. What it wants to know is find the side length. Oh, so we need to find S. All right, it says the height is 19 feet. So now we have to do algebra. So we're going to take, and I'm going to multiply both sides times 3 to get rid of the 1/3. I'll take my calculator, and so 912 times 3 is going to give me 2,736. And again, it's side squared times 19. And to get rid of the 19, I'm going to divide by 19 on both sides on my calculator. That is 144 is equal to S squared. And how do we get rid of a square? We take the square root of both sides. And that would be 12. So my side length is 12 feet. Not cubic feet. Volume is cubic. Area is squared, and just your length is whatever units it is. So each side length of the square is 12 feet. All right, so that is how you find a missing piece. All right, and let's go ahead and do one more. I'm going to do, let's see, something. We're going to need to find, let's find the height of number 14. Number 14, the volume equals 1/3 area of the base times the height. So the volume on number 14 is 392 cubic centimeters. Again, we'll leave the units for the end. And I'm going to draw this so you can see it. It is a triangular pyramid. So the triangle is the base. And the area of a triangle is base times height, 1/2 base times height, that's the area of the triangle, times the height of the figure. All right, so we got a lot of fractions in there, that's okay. It's 7 centimeters, and this is right triangle in here, and it's 14 high for that base. All right, so let's fill in a few things. 392 is the volume. 1/3 of the area of the base. The area of the base is 1/2 times the base of the triangle is 7 times the height of the base triangle is 14. And I don't know the height of the pyramid. So now I have all the pieces substituted in, and now I just figure it out. Since everything is multiplication, I don't need these parentheses, so I'm going to rewrite it again. 1/3 times 1/2 is 1/6. And again, how am I going to solve this? I'm going to multiply by 6 on both sides. So 392 times 6 is 2,352 equals 7 times 14 times h. I'm going to figure out what 7 times 14 is. That's 98. So 2,352 is equal to 98h. And what do? We divide off the 98. So 2,352 divided by 98 is equal to 24. So the height is 24. 24 what? Centimeters. All right, so there's 2 examples of finding a missing piece. Now, you can avoid doing all of this. The homework I want you to do, if you found pictures for section 5, you may do on page 639, number 3, number 11, and number 13. Otherwise, you have to do all the problems. Let's see, it originally was 3 through 17, and you would do odds. If you did not do the pictures in section 5, you got to do 3 through 17 odds on this page. If you did do 2 pictures, you can do these 3 numbers, or if you can find a pyramid and take a picture of it, that would be great. And then you only have 3 problems to do altogether. So good luck with that. And that is the whole homework assignment for this week. Have a great week, and I look forward to seeing your pictures and seeing how you're doing. Again, ask me questions by noon on Wednesday if there are questions. Have a good one.